Hi everyone, very good morning. I am Shubham Saloni. I work in a startup which is based out of San Francisco. We are in enterprise Wi-Fi and the company is called Meter. And before Meter, I was at Aruba. I was doing enterprise Wi-Fi again, like working on access points. And before that, I was at Broadcom doing the client-side chipsets. So yeah, I've spent like quite some time in the Wi-Fi industry. And today I'm here to talk about ML in Wi-Fi. And before I get started, I would like to express my gratitude to Dr. Shrikant for the opportunity. And anytime I like to do a presentation, I like to set a goal. And the goal for this presentation is to lower the barrier to use ML techniques on Wi-Fi data. I assume most of you are in the Wi-Fi industry working on some capacity for testing, production, things like that. So all of you do have access to Wi-Fi data. And the talk here is an adaptation of a course which I took at Stanford University. And I'll be like going really into how you could exactly get started, how you could play with data. And can I just see a show of hand for folks who use ML or like AI techniques in their day-to-day work? Is there anyone in the room? So we do have some, so this might be pretty basic for you, but I hope this can work as a refresher. And for everybody else, I hope this adds some value and you feel enthusiastic enough to start doing your own pet projects, play with the data, and have some fun. So this is our the agenda for the talk. Quick introduction, we just got that done. I'll go over some resources which are available for us to get started. Quick overview on Wi-Fi challenges and the need for ML. I think a lot have been said since morning, Dr. Sumit, and then Sai also pointed out like Wi-Fi itself is such a complicated space that there is definitely a lot of need, but we'll go over some specific scenarios also. Then we'll just delve into a few concepts just for folks who are entirely new to have some idea, what I'm talking about, what this whole shenanigan is about, right? Then we will delve into case study, which is going to drive a specific business outcome. And my goal with that is so that you could understand how I'm approaching the problem and why I am doing what I'm doing, right? So that you could map it to your specific problems. I want you all to be empowered to think about, oh, I have access to this data, and what kind of business outcomes can I derive out of this? So that's my goal. And we'll just end with some closing remarks and a Q&A. Okay, so let's get started about some free resources which exist. For any ML or AI to work, the basic thing is data. So let's figure out some of the easy resources which are available. So Kaggle is a website. This just hosts like lot of data sets. You could get a free login to it, and you could just search like Wi-Fi data, and then you will be able to figure out lot of different kind of data sets, and different kind of data sets will have its own like specific values, and then like based on your project which you're working on, because a lot of times when we just want to get started, you might not have access to all the data from your enterprise. So this you could like easily use for doing your own pet projects, for your own learning experience. And I think once you feel like more comfortable, and if you do have access to your company's data, you could actually show some results to your company and drive some business outcomes out of it. So this is one resource. Usually create something, and then you'll be able to see lot of like how the data set is, and when you see the data set, you could figure out, have access to all of this. So is there something which I can derive? Now let's get back. Yeah. Data World is similar. Another quite good resource which I recently came across is IEEE Dataport. This definitely looks much richer, and it looks like if you do submit your own data, you do get some credits and points and such things like that. This one also you could search. It's pretty nice. You could search a lot, and here if I'm like looking for Wi-Fi, let's just do this. hope it's fast. It's not, but it's okay. Maybe the Wi-Fi is slow, but we don't need to debug that right now. Okay, so here you could see there is like so many different kinds of interesting data available. Anytime, like if this is something you're just curious about, if this is something which has some overlap in the company you're working for, these can be an interesting resource just to like, figure out, okay, what kind of data sets are available, just browse and maybe pick something for which you want to start playing, playing more. So now you have the data, right? How and what do you use to start to dig into the data? So for that, this is a really cool resource which is called Google Colab. It's again free. You have a Google account, do have access to it. This is how this looks like. If you've ever played with like Python or you've ever played with data analytics and such, this might not be very new to some folks. This is similar to a notebook where you could write some commands, you can see an output, then on top of that write some few more things and then create another output. So this is something like that. I mean, you could check in more and then you could like create a new project. The very interesting thing is that Google gives you resources, which is in terms of it will connect you to a machine with some RAM and the processing power and all of that. And I think if you are really dealing with like huge set of data, you might go with a pro version or something like that. But a lot of for your personal projects, you might not need that, and this might just suffice. So when you have access to this, you'll have access to a notebook. Consider that as an IDE, okay? So you have this data, you will be writing few code to get some insights of your data, do some things more, and we'll be doing like really step-by-step process because I'll be going over a project. And that's my goal, like for you to like zero to something, right? So you do understand like where and how do we take steps. So this is another good resource. Okay, so now we have these two things done. Other things are programming. I think in today's world, it's a little difficult to get by without knowing Python because it's such an amazing tool for scripting and many things else. Even if you have not gotten exposed to it, it's easy. It's not that difficult to just get started. Anything, in any field to become a little more advanced takes more time. But to just get started, if you have known any kind of programming, it will be simply easier to, just get started with it. So basic Python skills, and then even in this, I kind of linked one resource which is in Geeks for Gigs, but you can find a lot, but I mean, read through one and then you might be able to, get like some insight, and this might not be a huge read as well. And then, I mean, Google also gives you a small ML crash course, which is supposedly you could do in 15 hours. Now when I say this, I understand like if you ever like Google something like this, you are suddenly bombarded with a sea of resources. There's this YouTube, this, that. And then sometimes you want to start and then you kind of really get lost, okay? So learning can become a really huge rabbit hole, and I totally acknowledge that. However, important thing is you can, just pick one resource, read through it. If you have like some doubts, those things you can Google and, just focus, read through one thing. And this could be a good, first level thing to start. Again, it's free. So now that we have set up all the resources which you have available for you, not so free is time and enthusiasm. Doing anything like that definitely takes a little bit of time, needs a little bit of learning mindset. You will fail, for sure. I failed. Like you will do, you'll be at times really frustrated, what's really happening. But then like if you really sail through, it will work and you learn a lot. And I think sometimes when you fail, that is really when you actually go into this deep diving into, why is this not working and all, and your knowledge actually enhances. So interesting, might take some time, but it's totally worth it, because from the morning, all the sessions, all you have heard, there has not been any talk without the mention of AI and ML. So it's just good to, just get exposed to it. And just, okay, what are these guys really talking about? Just have like a little bit of idea. You all are, experts in the Wi-Fi field. this is a good segue into just knowing a few things so that you can have a good overlap. Okay, so let's, before we go like deep into the project, which is where I'm going to spend chunk of my time, I just had this slide just to have an overview of Wi-Fi challenges and the need for ML. And I don't think I need to spend a lot here because from the morning, this is what we've been hearing. Network performance, network optimization, security enhancements. Dr. Sumit delved into so much, into complexities of increasing with respect to Wi-Fi 7 and 8 and all of that. Another interesting thing which is coming up is user experience personalization. So it is not, optimizing a network, but optimizing network for a user, right? So even you might be able to delve into things like that. And then, some things which are, this is more from an enterprise perspective, but how do you predict maintenance or support or things like that? Because a lot of time we mostly delve into, is the things are very performant. And forget to the operation side of things, because for an end user to get the best performance, even the operations need to be optimized. And when I say operations, that also involves setting up your hardware, upgrading them, maintaining the software, things like that. And if you see an image which I have in, yeah. So I'm going to test this also. I've not used it till now. Okay. So if you see this image here, I picked this from a paper. So Sisman and team had this paper I came across, and I really recommend if you have some time to go through this. This is, I really found this very enriching. They have done a survey of many papers which came before. This is a paper from 22. And yeah, I mean, this was really interesting. And by the time it loads, let's see, it's taking a bit of time. That's why we need AI for personalization, more bandwidth here. But yeah, so this one is a great resource. But I mean, if you're just starting out, I'll maybe use this for a little later when you at least know basic terminologies and few things. Otherwise, you might get lost on what these folks are talking about. Okay, so why I picked this diagram here is they have done this very interesting thing where they have categorized that increasing Wi-Fi performance is just not like one algorithm or one something, right? And here I did mention supervised learning, reinforcement learning, and unsupervised learning. We'll get little bit in depth on what these really mean. But from here, what I want you to take away is that not all problems are same, and different algorithms will apply to different problems. And you don't need to learn all the algorithms, but you need to know what is relevant in what kind of problems. And this is I found this to be very interesting from that perspective. Okay, so now let's delve into few concepts of machine learning. Let's get into, I might just like breeze through some of this, but I will still give you an overview because again I'll be talking more of this while I'm explaining the project which I did. So data and data handling, right? So anytime you have to apply a machine learning, and I'm talking about machine learning here, that would be a bit different from the whole AI. AI would be a superset of machine learning. So right now, this slide focuses on machine learning. And so any data, so you have this whole data set. So what do? Do you write a model on the entire thing? If that is done, how would you know that if this model is good or not, right? So you need to split the model. So for the entire data set, you'll have a chunk which is only for training. Okay, and in that chunk you can also keep some aside for validation, because when you have given your data set to a model, it's going to run the algorithms and it's going to train it, right, to figure out how am I going to work with it. So in that case, once it has trained and figured out something, it's going to use that to validate, and if it's not as proper, it's going to use that as a feedback loop. And now when I'm saying this, if you are a data scientist, if you're an ML engineer, you have to really worry about those things because you are the one maybe implementing those algorithms. But here we are just using it. And once we use, and those are like function calls. So low barrier, right? And once you have that, then you test that. Once you have created a model, then you test that. And the data which you have kept aside as the test data, using that you will figure out if this model was efficient or not. And if you figured out this is not efficient, then you go back and there are certain other optimizations which you can do. And this iterative process continues till you have a decent enough model there with which you can make some good inferences. Now let's talk about labels and features. So labels especially would be the variable which you want to predict, right? So in the talk before me, there was a discussion about DFS channels and things like that, right? So perhaps in that case, you would want to predict whether the clients can connect or not, right? And it's a binary decision, 0 or 1, client connected or didn't connected. So things like that, which you want to predict would be a label. And features are all these different variables. It's also called independent variables on which this prediction or the label will depend. And while I say about this is a good segue into our next topic, which is what are the different machine learning tasks which we can do. And there we are talking about supervised and unsupervised learning, right? So supervised learning here is where you have labeled data. And what I mean by labeled data is that X, Y, Z, if these things happen, then this is there. And that is why, I mean, if you would have anytime like kept yourself updated with some news, you would have known that data labeling is such an important thing. If it is a badly labeled data, your algorithms may not work that well. So supervised learning do need like labeled data, which means that similar, if channel is like this, there is interference like that, signal is like this, then this is how your behavior or experience is going to be like. So there are like some x1, x2, x3 variables, and you're determining a y variable right there. And the unsupervised learning is where it's not labeled. But this is more about figuring out the nature and how the data is. And this, like an example for this could be a recommender system, or it could be like anomaly detection. Things like if you have this whole spread of data, we'll just figure out what kind of data are more similar and what kind of data are not, right? So in that, nobody is telling you, okay, this is good or bad, or this is working, non-working, or anything like that. It's not labeled, but this is how data is like showing up when you're like running different things like that. And the most of the things which you do using these algorithms is a regression. Regression is when you predict. If you have X, Y, and Z, what will Y be? So that's more towards prediction. Something like, okay, you have like a number of clients. This is a channel, this is the area, all of that, and then you want to predict like what your throughput is going to be like, or requirements might be like. So that could be one example for regression. The classification, these are like, I'm just going to say, these are bundle of different kind of machine learning algorithms. Classification here would be that you're classifying things, right? Can this use DFS or not? Things like that. It's a yes or a no answer. Those kind of things will be classification, and later we'll be delving more into a classification problem. Clustering, again, unsupervised learning, you're grouping data, you're checking like how data is behaving. Once you have, identified you have data, you've identified what kind of machine learning you want to apply on it, then comes evaluation of the performance. And important thing here, two terminologies, I'll just like briefly touch on this, is overfitting and underfitting. And what that really means is, if you have data and you've trained the data in a manner that any input you give, it gives you the result, and it has been like done in the way of the, like the way you have trained it. So if the input was X, you got Y. So the model is in a way that whenever it gets X, Y, Z as input, it will give you Y, right? So what happens is that might not work as well for new data, because what you did, consider that as a really humongous if-else statement, right? Like if X1, X2, X3 is this, Y is that. And that doesn't work really well with good data. So then you would not want to do that, but you could end up in underfitting where you have generalized it so much that whatever prediction is happening is not that great. So there are like ways how you could, reduce these things. We might touch a little bit on those things. Training and optimization, again, like once you have your model and you've figured out the performance, then you could like find more things to tune it so that it becomes a little bit better. And end of the day, like how you conclude, oh, this is good enough and I can make some conclusions out of it, is using some outcome metrics. We'll dive like more into the classification one, but yeah, so each algorithm does come with its own what would mean for the model to be good. Oh my God. Okay, I will still open the link. I think this is already open here. Yeah, sure. So I will just like breeze through this. This should be not that, I will not get into depths of it, but you feel free. This is a online project anyways, and you can, it's also linked on my LinkedIn profile. Here, first thing is you get the data, and it's just like you have to add it in your Google Drive and you can mount it, you have that. Once you have like all the, these are really standard. If you like look online, you might find a lot of these. So this is just like any other resource, you're like, including header files and, all of that. Once you have data, you will, just check how the data looks like. In here, we will clean the data because a lot of time you have like lines which doesn't have like right values and things like that, and if you like right away take a raw data and put an ML algorithm, it might not give you good results. So you do need some pre-processing. Yeah, and then this is just part of how you looking how the data looks like. This part is just like these are all like different what to say, columns here, and I'm just like checking what the values are. We do see that all of this is coming from one organization, so this is definitely not a good, I don't need to use this column in my mix. So a lot of these things you will get to know. Pre-process, remove the redundant ones, and then here I just picked y as a dependent variable which I'm gonna predict, and that was like what's the outcome. So this data was the client density, how many clients connect to an AP, and on what's the geo of the device and what time and date, and this data had all of that. So here I just picked the dependent variable y, which is I'm going to predict as the presence which was the capacity, and then you would have geolocation, month, and those things I picked as x. So the y will depend on these x, and then and then this was a huge data, I dropped everything else, and now I have like these my x and this is going to be my y. Then I'm just going to like plot some things just to know how the distribution looks like. If I'm going to find something interesting here, it's very correlated, things like that, I might just drop it. So you still need to do this so that later you can run an algorithm with a clean data and something where you could find something good. This is just like seeing the distribution. Again, like the number of devices here is a number, like 60, 70. And I here want a classification algorithm where I want to know whether it's high or low. So this is just like I'm transforming that column into a binary format. So this is this. So I'm just like changing that. And then like once I have changed it, I might also check like if data is divided, I don't have like too many high and very few low, because then again it will be an imbalanced thing. So luckily here it wasn't like that. I did see like it was kind of similar with ones and zeros, but if this is imbalanced, you might again have to drop some and balance them. Once that is there, another thing is like day of the week is like Sunday, Monday. These are not like zeros and one, and any machine learning algorithm, because it is machine, needs a number. So this is also a way you just like convert data into number format, which is just it will do something like this. And all of this is like, just creating dummy variables out of it. So essentially, this is your final data on which I'm going to start like fitting a model and trying to find something. So once I have this, and I know I'm a little bit short of time, so here you could run something which is called a correlation matrix to know if all these different x values which I've picked are interrelated. And if you find something which is, then you can still drop them. It's again like part of data cleaning. Once you have everything, this is where, that splitting is happening. Train, so I have just split 75 to 25, so training on 75% of the data and 25% is what will be used for testing. And once I have that, to fit a model, all I did is call this function. This is a little advanced topics, you can like figure that out on your own or find me and we can talk about this. And eventually like you get a model, and once you have a model, then you can check. So this is, I'm just quickly dumping the values. Here I'm just like checking how good this model was. This is about performance analysis of a model for actually predicting something, right? So here, when it was 0, it predicted it this many number of times. Here it was incorrect. And using that, I figured out these values where you could see accuracies, how good this model is towards predicting. And based on your problem, you can figure out a little bit more about precision is how good, when you say something is positive, what's the probability of it being really positive, right? So from those values, I think eventually you get a F1 score, and higher the F1 score, the better your model is. Here we could reach 85%, which was kind of good. And then here we do have, this is just like another curve which you can plot to figure out how good your model is. And usually something which is, so this is like true positives and false positives, and the more in this direction is good. And I think once that is there, another really cool thing here is that you can figure out, among all these X, which has the most impact on the model or in, predicting Y. Because we have here many variables, right? Does the month really determine when the devices are high, or is it the geolocation? So this is something which can give you that dump. And from here you will be, and then there is another like a tool which you can use, which can also tell whether it is positively correlated or negatively. Whether if it is, geolocation is high, but if it is this geolocation, it's actually like device counts will be lower. So once you have all of this, I'm just going to come to the business outcome which I got from all of this. If I want to do capacity planning, I do know that there are few geolocations where like if I deploy high capacity Wi-Fi access points like 11AX and such, it will be more beneficial, and that is a real business outcome. And then maintenance window, right? Like we did see when the client counts are really low, and looks like a Sunday in September will be the best to do. So yeah, this is pretty much what I had. Yeah, thank you. Yeah.